Hello, and welcome to Exploring Axon, a podcast where we discuss Axon and its ecosystem. I am your host and Axonic developer advocate, Sarah Torrey. In today's episode, I will be speaking with Allard Buijze about event streaming and event sourcing. We will also talk briefly about Axon Server. I hope you enjoyed this episode, and let's have a listen. Hi, Allard. How are you?
Hi, Sarah. I'm doing great today. How are you?
Good. I'm doing great. Thanks for joining me once again to talk about some really cool stuff. So last time I was speaking with Stephen, and we briefly talked about event sourcing versus event streaming. So I'd like to go into a little bit more detail with you on that today, and just talk about the two concepts and the differences, and which one is better to use for certain situations, and just go from there, if that's okay.
Yeah, sounds perfect.
Perfect. So I recently came across this really neat article by Vijay Nair, who talked about the event sourcing and also event streaming. And it was very useful because I want to talk about this with you today. So he mentioned in that article that a system of events let me go back a little bit. He sort of elaborated on event sourcing and event streaming, and he talked about the event sourcing to be a system of events rather than a system of state. Am I correct, or am I getting it backwards?
No, correct. Yeah.
Okay, great. Fantastic. And he said, in originating from the domain-driven design world, event sourcing advocates the design and development of applications by treating it as a system of events rather than a system of state. Can you elaborate on that for me a little bit?
Yeah. So basically, this comes down to what is the origin of the decisions your system makes. So in traditional quote unquote systems, we tend to store states, and any decision that you make then looks at that state and says, oh, the flag is on, or a flag is off, or a value is higher or lower than a certain threshold. So I am, based on that information, I'm deciding to go left or right, or to do whatever a system needs to do.
Mm-hmm.
The problem
And,
with that is that decision will then generate new states, which
mhm.
overwrites the previous state. So you lose track of any reason why you've made a certain decision because you're
And can you tell
overriding.
me, what do we mean by state in this case? If we change something within, say, an entity or an aggregate, is that what we mean by state, or is it more of a
So
general term?
in a when you're looking at states, you just see how things are right now, right?
Mm-hmm.
That is, so what is the information available in the system at this moment, right? That's
Mm-hmm.
what
Yeah.
that's what we're looking at, and that's basically
Mm-hmm.
the state of your system. And typically, state translates to the values of certain fields and columns in a database.
Right.
Right? That is,
Perfect.
in practice, mostly what is referred to as state.
Mm-hmm.
It
So
does
now what? Yeah, go ahead.
it does get a bit more elaborate than that, because state is not always in databases, and it's a combined state of the version of the actual code deployed as well
Mm-hmm.
as the information in the database. So it does get much more complex, which is only more reasons for event sourcing to be so interesting. But I guess we'll come to that in a
Yeah,
second.
we'll get to that. Yeah, absolutely. So, can you tell me a little bit about event streaming? What is an event streaming? Let's start with that, because as far as I've read about event streaming, again, there was the article by Vijay, and there was another article that I came across by Jesper Hammarbäck, that they were talking about, of course, the event streaming would be for publishing or subscribing to a stream of events and then storing it and then processing the stream in real time. So let's talk a little bit about that and see what that actually means.
Yeah, so event streaming is basically the process where, imagine there's two systems that need to keep each other up to date. So one
Right.
way would be for the receiving system, or the system that needs to be updated, to just
Hmm.
poll the first system and say, hey, give me your state now. And then two
Right.
seconds later, give me your state now. Then you can keep it up to date, right?
Right.
Things get a bit tricky because that system might not be interested in the state, but it might be interesting in deriving something that happened, Well, doing that from that state becomes really, really difficult.
Right.
And it requires both systems to be up at the same time, which is
Mm.
sometimes problematic as well.
Absolutely. Yeah.
And that's where the concept of event streaming comes from. Instead of sending the current state over upon request, why not get a continuous stream of changes going to that other system? And so
Right.
every time something happens, you just post a message on a queue on some pub sub platform, and just post a message there. And any component that is interested in staying up to date can just read from that queue
Right.
and updates its own state accordingly. And if you
Right.
design that correctly, the events describe actual deltas. So not only do you know what the new state of the system is, but you can also transfer knowledge about why that change happened.
Right.
Right? Did your account balance just change? Well, it doesn't. No, it doesn't. Account balance doesn't just randomly change for no reason. There's an obvious
Right.
reason.
Yeah.
So you've been shopping, or you've just received your salary, or whatever, and that is more valuable information. And that
Right.
is what event streaming is about. Is about get that, describe that delta, and describe a bit more of the why the change happened, and get that as a continuous flow to the recipient. And then the recipient can choose whether to update that in real time, or well, depending on the messaging platforms. Kafka is a very popular streaming platform nowadays,
Right.
and they allow you to even be offline for a while and start streaming in a couple of hours, or to right? So you have much more choice on how to get information from one system to another, and not both systems need to be up at the same time anymore.
So then, what would you say the benefit of event streaming could be, and what is the downside of using event streaming?
So with event streaming, you're now transporting deltas to another system, and that other system is making assumptions on the information it receives. If there's anything erroneous in that event stream, and that can go two ways. You could have an event of something that happened which you've actually wanted to roll back on the producing side, or events might be produced twice accidentally, and then the
Right.
consumer might believe it happened twice. Well, it didn't happen twice; it was accidentally reported twice.
Ah.
So you have those differences where the event stream now becomes the truth for the recipient, right? It is the
Yeah.
only thing that the recipient has to act on, so it needs to consider that to be true. But the problem is the event stream is not inherently reliable, because you
Exactly.
depend
Right.
on the producer's quality to produce a correct event stream.
So then, let's talk about the storage of these events. In event streaming, I know there's an option, for instance, in Kafka that you can store these events. Is it a reliable way of storing these events, and why does that matter?
Yeah, so for event streaming, yes, it is a very reliable way of storing events, because basically it has a store and forward semantic. So everything that gets published gets stored, and then any consumer will be able to read that. And the way they operate with the consumer gets these positions of where it left off. So if it loses connection, it can actually exactly continue where it left off, because the information is stored. But in Kafka, it's designed to be stored for a limited amount of time. Now, that
I
amount
see.
of time can be set to a very, very, very long
Long
time,
time. Yeah.
like almost indefinite. It is
Right.
Nothing is ever indefinite.
Yeah.
Um, but and that allows a consumer to be offline for a while and still go back, or when processing logic changes, it does allow you to go back in time and restream those events.
Right.
And that is a very so for event streaming, and I have to stress that part. So we're still talking about event streaming. Yes, it
Yeah.
is
Yeah.
a very reliable way of doing that.
So now let's talk about event sourcing, and let's talk about why would we use events sourcing versus event streaming, and also then I want to highlight on event storage requirements for event sourcing and why that's good, or what are those requirements at all?
Yeah, exactly. So yeah, there's been a lot of misconception about event sourcing and event streaming, and in the situation I described before, when you have the system A and B, and A is producing events and B is consuming them, that is event streaming. B is not an event sourced system; it is a system that consumes an event stream.
Right.
Event sourcing does not involve B. Event sourcing
Ah,
is something that only involves the emitting side, the
I
sending
see.
side
Uh-huh.
of the event stream. And it
Gotcha.
is about how that component A makes decisions to post new events, right?
I see.
And
Okay.
it it is crucial that a component that does event sourcing will make those decisions based on the exact same stream that it publishes to.
Okay.
So of course we need for decisions we need to have the flags, right? We need to have thresholds of something like in an account balance. If you want to transfer money, you have to have that amount of money on your balance, right?
Okay.
Or
Yeah.
you should be allowed to overdraw, but but let's keep it simple for now.
Yeah.
So we are interested in the current state of that account in order to fulfill that money transfer request.
Right.
Now, um, in event sourcing, we don't have state anymore. We don't have the current state of the balance anymore, or of the account anymore. So if we want to get to the balance, the way we should do that is by looking at all the events that we emitted that impact the balance, and then recalculating what the current balance is. And that sounds maybe a bit extreme. It sounds like it doesn't perform, but it does, right?
And
There's
that's what we
definitely
talk
ways.
about. Right. And that's what we talk about when we talk about a single source of truth, because then you have everything basically laid out in front of you so that you can go back to it. So we can change those events, but then it gives us a really good overview of everything that has happened up to this point. Right. And that's
Yeah,
important, I
exactly.
think.
That's definitely one of the upsides of event sourcing. But I would
Hmm.
say the major advantage is that it makes that event stream, which is so powerful in interacting with other components, it
Yeah.
makes that a reliable source of truth because all the decisions are based on the information in that event stream.
Right.
And the only way to post a new decision and change the behavior of that system for future decisions is by putting another event in there. So that
Right.
way we have a guarantee that the event store or the event stream that we get as a result
Yeah.
is the truth, the whole truth, and nothing but the truth. Right?
Right.
It's impossible to get something that did happen missing in there because if it's missing, then the system doesn't make any decisions based on that information because it's not there. If it made
Yeah.
a decision, the only way to propagate that decision is to put it in that event store.
I see.
And that's the big difference between event sourcing and event streaming. But I would say event sourcing implies event streaming, but not the other way around.
Gotcha. So then I also want to touch on sort of as we're storing all of these different events and we're constantly adding to these events in event sourcing, we're not deleting anything. Events are immutable, right? Um,
Correct.
how does it work with databases and the speed that we're working with? Does it slow it down at all? Can you elaborate on that?
Yeah, so you can imagine that. Well, basically, databases work like this internally themselves, right?
Yes. Yeah.
They append entries into a transaction log, and every time you make a change, you just append an entry and apply that change. And that's because applying a small delta is a lot cheaper than modifying existing state.
Right.
Um, so yes, your data will grow. You will store a lot more information, but then that information is valuable. You
Right.
can choose to store it for a while or to store it forever. But with event sourcing, it's typically forever by default, and
Yeah.
then you can make it any shorter if you allow yourself to lose that part of your history.
Right.
Um, so yeah, it does give you more storage. In terms of performance, it is not actually impacted that much in a negative sense, and in some cases, it is even faster. There's a lot of things you can do to optimize reading. And it
Right.
makes it a lot safer to, for example, put a cache in front of it, because as soon as the cache invalidates, you get a notification.
Right.
Right? There's an event, and that event basically makes the previous information you had stale. So
Yeah.
you'll get triggers when these caches can be invalidated, and that makes event sourcing a process that is fast when appending new events. It might be a bit slower than traditional when reading, but it gives you a lot of features to optimize. There's
Right.
snapshots you can create, which in Axon framework are very easy to do. And they basically limit the number of events you need to load to get to that, to recalculate that current state. So there's an immense amount of possibilities to optimize that, which in the end make it simpler and faster than traditional state storage.
Yeah, and I want to come back to this and talk a little bit more in detail with regards to Axon Server in just a minute. But before we go there, can we talk about consistent rights also in event streaming and event sourcing? Because in event streaming, we talk about, for instance, one way of doing it is by using optimistic concurrency control or using a single writer. Can you sort of touch on those a little bit and explain to me and everybody else what those are and how we can use them, and then with event sourcing as well?
Yeah, so with event streaming, there's always a challenge of what if you emit conflicting events? Well, what if two components or two instances of some component make a decision somewhere, but they don't realize, well, they need to somehow realize at some point that they are making a conflicting decision,
I see.
right? So imagine you are at the ATM withdrawing money from your account, and your account balance is sufficient for that withdrawal.
Right.
Meanwhile, your partner is in the store buying something, and buying something that the account balance is also allows that, right? But for some reason, you cannot do both. Your account balance is not sufficient for both. Now, I've seen it unfortunately more often go wrong than right. But in traditional systems, we have to be very careful about locking, right? So
Right.
what if the system checks your balance, and then your partner's transaction also checks the balance, and they both get an okay because balance
Yeah.
is good, and then we
Right.
execute those operations, and
And then you
now
get
you
an
go both home,
overdraft.
you get an
Yes.
overdraft, and actually
Exactly.
banks often allow that,
Yes,
even
they do.
though because they can just charge you immense amounts of money for it.
Exactly.
But before we piss off our all our banking listeners, um,
Exactly.
so
There's a better way.
there's better ways, and this is
Yes.
basically where and event streaming solutions don't do that. For example, Kafka, it will not validate anything for you. If you post a message on there, it's just a message. You put it
Right.
there. So
Yeah.
it's your application's responsibility to make sure that you never post a conflicting message. And you can do that with optimistic concurrency and pessimistic locking, if you will. Pessimistic locking being where you say, "Hey, I'm going to work on this balance. Don't touch anything
Right.
until I'm done." In that case, one of you will have to wait at the ATM slightly longer.
Yeah.
Um, or the other option is to say, "Well, we'll accept both transactions, but if we find out last minute that something else changed, we'll reject it after all. We'll just give you, we'll roll back the transaction if
And
we
you'd have
find
to
out
do it
something
again. Yeah.
else." And yeah, you'll have to
Yeah.
try it again, and then it will fail because the balance is not sufficient anymore. So it's
Right.
really about what the one to choose is about the possibility of conflicts, which in CQRS-based systems is so interesting because we have a special component for commands for changes. So we
Yes.
know when something arrives there, we have approximately 100% chance of a change happening,
Right.
which is why I believe that in CQRS-based systems, pessimistic concurrency control is a lot more efficient, because there's no point in allowing two commands, so to say, make changes, because you know the changes will result or are very likely to result in actual changes,
Right.
and then you need to roll back one of the two. Well,
Exactly.
if you know that, why not serious and execute them sequentially if you know
Mhm.
they are conflicting, right? But that's
Right.
going back to aggregates, and we discussed those before.
Yes, which is great because if your commands are already taking care of that, then you're basically preventing having to later on deal with, your. It kind of does the job of your optimistic versus pessimistic logging for you a little bit right at the
Exactly.
beginning,
Yeah.
so you don't even have to worry about that. Yeah, so that's really really beneficial for me to know at least. Can we go back and talk a little bit more about event storage requirements in event sourcing? So we know that in event sourcing, especially in Axon framework, we have the usage of aggregates and all since point in time, and read back and write order and all of that wonderful stuff that you talked about in one of your talks. So if you don't mind just touching on that, I don't mean for you to repeat that whole talk again, but you can sort of highlight some of the points for me.
Yeah. So the thing is, when you want to use event sourcing, so if you want to upgrade your streaming experience with event sourcing, that also
Right.
puts some extra requirement on the event storage.
Mm-hmm.
So
Yeah.
not every system that stores events is an event store, right? That is very important to realize.
Okay.
And that is
Mm-hmm.
because of some of the extra requirements, which are exactly the topics that you mentioned. So when we look at the scope of event sourcing, the scope is an aggregate, right? An
Right.
aggregate is that unit of consistency that we have where we make decisions, and those decisions
Mm-hmm.
need to be consistent.
Right.
When reading events, we will want to read the events that are relevant for that aggregate and
Right.
just apply them to, well, an empty first version of an aggregate so we can recalculate the current state. So we're not
Yes.
calculating the current state of the entire system every time.
Mm-hmm.
We are
Mm-hmm.
just limiting that to the aggregate.
To the
Well,
aggregate. Yeah.
that means our event store needs
Mm-hmm.
to efficiently retrieve the events related to that particular aggregate. If your system doesn't allow that, then we need to go back across the entire history and just stream everything and filter everything out that is not relevant. But you can imagine
Yeah.
in a system that has millions of aggregates that you're interested in 1 in a million events, and then
Yeah.
that's not
You're gonna
feasible.
be waiting forever.
So
Yeah.
you're going to be waiting for a long time and optimize
Yes.
on the wrong things in the meantime.
Yeah. Mm-hmm.
So Axon Server has a storage which is designed for event streaming in mind, but
Mm-hmm.
also event sourcing, which adds a few extra guarantees.
Right.
And one of them is it keeps track of the positions of events relevant for a specific aggregate. So
Mm-hmm.
we have special indexes in place that allow you to very efficiently find the events that are relevant for recreating the current state of an aggregate,
Mm-hmm.
realizing that most recent events are more likely to be accessed than the older events.
Right.
So that's on the reading side to
Mm-hmm.
optimize for the reading, and then we have
Right.
some challenges on appending new events.
Sure.
So one thing you definitely don't want to have is when an aggregate um, produces an event, it made a decision, right? So it
Right.
produces an event to let its future self, but although also other components know that that decision was made,
Mm-hmm.
and it wants to put that in the event store. Now, theoretically, there could be another instance of that aggregate on some other machine somewhere else that also got a command and is
Right.
also processing something. There's no way
Mm-hmm.
to stop that in
Sure.
distributed systems. But one thing you don't want is both of those conflicting decisions to make it to the event store. You want
Ah.
the first
Okay.
one to make it and the second one to be recognized as conflicting.
Yes.
And the way we do that in the event store in Axon Server is we basically have a sequence number per
Mm-hmm.
event from an aggregate. So the
Yes.
combination of aggregate identifier and sequence number has to be unique.
Mm-hmm.
And that way we can easily detect whether, let's say, an aggregate read 5 events to get to the current state. When it makes a
Mm-hmm.
new decision, that's event number 6, right?
Yes. Mm-hmm.
If another one made the same decision or a different decision, but based on the same events, it will also append number 6. And now
Yes.
we can recognize that that is a conflict. And that is another feature that many streaming systems, they don't care about that. They don't
Mm-hmm.
care about that concurrency control. But for an event store, that is a very important mechanism to have. and is basically the last line of defense to make sure that any decision that gets appended to the event store is a decision that does not conflict with any other decisions made.
And I think that what you mentioned about the sequence numbers as well as the aggregate identifier being unique is very important, because as we're going through the state changes and looking at the events and the history of, let's say, that aggregate, I think it's important to have that in order. Whereas streaming, you don't really have that order. Things can come in different orders. You have different events in different orders. So going back in history, and as you mentioned a little bit earlier, if you're looking for a specific event or state change, then that becomes very difficult because you don't have things in sequence, and so that can be really, really confusing to go back and have a very consistent history of your events and aggregate changes and everything.
Correct. I mean, message ordering is and will always be problematic and challenging.
Yes.
And the thing that that aggregates give, and it's not even so much event sourcing that gives you a guarantee, but the fact that you're designing aggregates,
Yes.
it gives you somebody used a nice
Another
phrase.
layer of protection, I guess.
It's a layer of protection, and somebody said it's a little island of consistency in a river of constant change.
I like that.
I really liked it because it is a small island. Everything flows, but you know, at least on that little island, I know that one thing happened at one after the other.
Yes.
Right? Things do not happen concurrently on that little island. But in the meantime, of course, there's different parts of the system, and they're making concurrent decisions.
Yeah.
But that ability to just make small consistency boundaries is very important.
Exactly.
So, yeah.
Yeah. And one of the things that you mentioned today and also in your talk previously is when we talk about append events or snapshots. I know that we do have a feature in Axon Framework that's called a snapshot. Is it referring to the same thing? Is it sort of on the same path of what we're trying to get out of these events that we're appending, or is it something completely different?
No, it's definitely related to that. So the just imagine that you want to know, you see something you want to buy, and you want to know if your account balance is sufficient to buy that.
Right.
Then well, you can do two things. You can go back and to the moment you get your bank statements out of the wherever you put them, the shoebox or whatever.
Yeah.
And you
In
start
the
at day,
mattress.
you start at day 0, right, when your balance was
Yeah.
0, and then you calculate everything till now.
Mm-hmm.
Well, by the time you find out what your balance is, probably the item you wanted to buy is gone.
Mm-hmm.
So that is not a very efficient way of getting to your current balance.
Right.
And you can imagine that in a system, if you need to recalculate the current state based on all of these events from the past, well, there's only going to be more and more over time. So the time it takes to get to the current state will get longer, while you probably get more users on the system, and you just want it to be faster instead of slower.
Right.
So there's a mechanism called snapshotting, which allows you to create a snapshot of a point in time where you say, well, to get to the current state of my aggregate up to that point, I've loaded all these events.
Right.
So I can create a little snapshot of my aggregate and say, when I streamed everything up to that date, this was the state I had.
I see.
So let me store that state and refer to that position. And now if I append new events, when I need to recalculate this current state, I can take the last snapshot, and that snapshot will tell me, oh yeah, the first 50 events, that means this is the state. And now I can read the events that came after that particular point in time, and retrieve those and recalculate the current state. So basically, snapshots are a replacement of reading historic events, just to make aggregates load faster. That's the only reason they exist, to make the loading time of an aggregate faster. And of course, you can use caching as well to make it faster. The problem is when you have a cache miss, you'll have to go back and load the actual aggregate from the events. So typically you see both snapshots and caches together to make sure that, well, caches make the retrieval very fast and almost constant time, but when you have a cache miss, that you cap the amount of time needed to reload it from disk, quote unquote, so that you don't get massive delays in reading the aggregates from a repository.
Yeah. So since we're on the topic of speed and functionality, let's talk about Axon Server. Can you tell me a little bit? Now, we will have a different episode talking specifically about Axon Server, but just in sort of brief explanation, why did you come up with Axon Server? And I think it's important that we know why Axon Server uses different nodes. I think that's something that was interesting to me.
Yeah, so the reason we started building Axon Server is basically twofold. So Framework has been around for 7 years before we started building Axon Server, and the reason is we asked the users of the framework, like, what are you doing with the framework, and what are you missing, or what are your top challenges? And basically they came back with two challenges, and one was, well, the messaging, to get the commands routed to the correct nodes, and the queries as well. That was a challenging aspect. But the other one, more relevant to today's topic, was managing the sheer storage volume and making sure that it did not slow down.
Right.
So the problem is that a relational database is a perfect event store. So very often when you read about people using Kafka for event sourcing, read carefully, you'll see that they do the actual event sourcing with a database in front of Kafka. They do the streaming on Kafka and then the event sourcing with the database in front of it. But of course, that doesn't sound sexy, so we do event sourcing on Kafka. But a relational database is really good functionally at doing that, because it can give us the insert guarantees. It gives us a relatively reliable form of ordering when we read things, and the durability, of course. But the problem is these indexes are not designed for ever-growing systems, and they don't take into account that newer events are more likely to be accessed than older events. Right? A database is random access. It's designed to update any row at any time.
So I'm glad you brought up random, because we talk about a lot of times that we want to be able to look at things sequentially, and relational databases don't necessarily do that, correct?
No, they're not designed to do that, correct? Yeah. So they're designed to get any data from anywhere at any point in time, and so we noticed that there's an immense slowdown as your index grows out of memory, or when at some point the indexes are so big that you have to do disk I/O every time you want to look up something. And so we set off to find a solution for those challenges, and basically that is where we built Axon Server, an event store that is focused on the actual operations that you will want to use with event sourcing, which is append events, read events for an aggregate, and then read all events sequentially. And it's really designed to do those efficiently, not suffering from performance loss as your data grows. And we did some interesting benchmarking on the very first versions of Axon Server, just to prove that we did indeed have that linear access time every time we appended events. And after storing several billion events, we noticed that yes, it is still at the same storage volume. Whereas with a database access, we had to stop after a few 100 million events, because they were getting so slow that it was just taking too long to get to a billion. And of course, there's a lot of scalability things you can do. You can grow the cluster, or you can grow your the memory, but that is not a reliable way to scale a system, right? You can throw more hardware at it, but at some point, it just gets too expensive to be a sustainable solution. So that's one. But another aspect of Axon Server that we wanted to solve was the durability of data, and also the reliability of, the availability of the system. And we realized that while databases do support clustering, they sometimes have challenges. We've had challenges with master setup on MySQL, where it had a conflicting insert on both nodes, and then it just stops replicating. It
Oh,
just
fun.
stopped. Nothing happened.
Oh my
So it was
God.
a read-only database from that point. By the
Oh,
time you
great.
find out and you get to resolve that, your system has been offline for a little while.
Yeah.
So we wanted to make sure that we had a system that was available, yet had a very strong consistency guarantee. Data
Yeah.
consistency is the most important with event sourcing, because
Mhm.
your event stream is your source of truth. You better have
Exactly.
that consistent, right?
Right,
So
right.
so to not suffer too much on availability,
Mhm.
you've probably heard about CAP theorem, right? Basically, you
Yep.
have to interpret it as, given a network under a network partition, do you prefer
Mhm.
consistency over availability, or vice versa? Well, we
Mhm.
need consistency for sure, but we want to
Exactly.
minimize the availability problem, and that's where clustering comes in. So you can set up Axon
Mhm.
Server as a multi-node cluster.
Right.
We use the Raft consensus algorithm to elect a leader, and that leader
Mhm.
is responsible for coordinating the transactions and making sure that whatever data you insert is actually durable. It is stored on a
Yes.
majority of nodes, etc.,
Mhm.
so that when any node fails, you will still have the consistency guaranteed. If
Right.
too many node fails, that's when you suffer availability, because then we choose to not store anything because we cannot guarantee the correctness of the data anymore.
I see. And I actually just learned about Raft system with Axon Server, and I thought that was like really neat when the leader election happens and how the availability of the nodes work that way. So I will definitely do a bit more detail on the Axon Server episode, because I thought that was a really, really neat idea. So just to wrap up our conversation, so we do event sourcing, obviously, in Axon framework and server. Where would you say the event sourcing works better versus event streaming? Obviously, we talked about a lot of the pros and cons and everything like that. But just to kind of wrap it up in a little sweet bundle, where would you recommend it?
Yeah,
Where would you not recommend it?
I'm afraid I'm going to disappoint you on that question, because
It depends.
if you it depends. Yeah, if you asked me that like 5 years ago, I would have said
Mhm.
event sourcing is only for the systems where you have very strong auditing requirements or very clear value on historic
Mhm.
data.
Yeah, that
Um,
we talked about
so
before, like financial institutions and
exactly,
accounting, things like that. Yeah,
those are
but
the
we then
obvious ones.
noticed that and
No, that's
there
not
are some
true
not
anymore.
very obvious ones. Yeah.
Exactly. I've seen so many. So basically, I have a few quick tests when we talk to
Hmm.
prospect customers. I have a few questions just to validate them. Right? Are they the right
Yeah.
customer?
Yeah.
And basically, it comes down to, are you using event sourcing for the right reason? Are you not
Hmm.
confusing it with event streaming? And I was surprised by how many use cases there are where just getting the current data and just getting that reliable event stream is
Hmm.
so powerful. And that's
Yeah.
because it's not only, you don't just have a source of truth for the future and for analytics,
Hmm. Yeah.
but it is also because in distributed systems, you want every system to reflect the truth at some point.
Yes. Yep.
And
Yep.
you really don't want to run the risk of your event stream to become corrupted by a very small mistake. And somebody made a
Hmm.
mistake at some point and
Yep.
decided it was a good idea to just evict that one event from the event stream, and
Right.
not realizing that some components may have handled it already, some components
Yeah.
didn't. And then
And so you don't
suddenly,
have the whole picture.
exactly. And
Yeah.
worse, you've got five different pictures. Now,
Yeah, that's
different
great.
systems will give you different truths, and they're all
Yeah.
based, right? They all have their own truth.
Right.
And in a recent discussion, I was reminded of a big outage at a Swiss bank a couple of
Hmm.
years ago, and that was due to systems speaking different truths, and then, well, every system just looked at another system and derived
Yeah.
its own truth from those truths, etc.
Hmm.
Well, you get one mistake in there, and it just cascades, and it grows to a big problem. I mean,
Yeah.
that's what most sitcoms are about, right? It's
Right.
somebody not telling the truth, and then it really gets annoying until it really explodes at the end, and everybody gets
Hmm.
happy. Well, in
Yeah.
IT. it's not happiness at the end.
Doesn't work that way. Yeah.
It doesn't work that
Yeah.
way. Things explode and people lose jobs. So you really want to make sure that your event stream is correct and
Mhm.
truthful. And then the second benefit is, but if we keep the data for longer, then we can also do the analysis. But it's
Right.
that capturing the truth that is so valuable, especially now when systems grow more complex,
Mhm.
and more distributed.
Yeah.
We really need to have some reliable source where we can derive all of our information from.
Information from, yeah. And I think it's really valuable to talk about this because you and I had this discussion a while back, and when I first started with the team, and I was asking you all sorts of questions about like, where would you use event sourcing, like which businesses can you use it in, and you were like, well, it just depends, there are a lot of different ways to use it, and different businesses use it. And I just recently started working on this little side project where I'm building this very small, tiny app with maybe like 3 aggregates, which is all about scheduling music lessons. And the reason why I wanted to experiment with that, and some of our listeners may not know this, but I was a music teacher for like 20 years. And during my years of teaching, I always had this struggle with some of my customers, some of my parents who brought their children to take lessons. Earlier on, the way that my accounting system worked was that I would charge people cash, and then I would have to report it to the tax office, and then go from there with the taxes, yada yada. The problem was that after several years of doing that, and then I had to change it into an online banking where everything was done through the online banking. That also had an issue because a lot of times we go back to the single source of the truth. Because I would say to parent A that, for instance, you missed a payment in this month, or you missed, one of the payments was missed, but your child was sick, so I'm giving you a credit for next month, something like that. The ordering of things and keeping everything in track became so complicated and difficult because I didn't have my single source of truth to go back, and I didn't have all of those events logged in, um, to really go back to it and show that, okay, this is what we did and this is how it's going to work. Now, years ago, if I had this knowledge of event sourcing and I could have this application and just go back and record everything, every event for each student and each lesson, and with the payments and missed lessons and all of the wonderful little details that come in with when you have your own business, it would have made life a lot easier, I think, for both parties, because then you can go back and look at those events and say, okay, this is what happened. And because events are immutable, you can't change it. Well, if you missed a lesson, you missed a lesson. If you missed a payment, you missed a payment, and it makes life a little bit easier. So I think I have a really good, not a good, but a huge respect for it now, because it would have been very helpful if I had this tool several years ago. So yeah, I'm totally
And I think
in belief of this. This is a good
this
thing to
story
use.
proves that it's so much more valuable to know how we got here and what happened that
Mhm.
got us into this place,
Exactly. Hmm.
especially in basically support discussions that
Right.
you're having with your customers. It is so valuable to know how we got to the current state,
Yes.
and just knowing the current state. And yes, you could have used flags or post-it notes on the wall to say, I
Hmm.
reminded that particular customer of their payment.
Yeah.
But then they will argue that was my first reminder and I only got
Yeah.
it 2 days later.
And
Um,
talk about snapshotting and going back and looking in your like thousands of emails that you sent, and like,
oh
this
yeah,
is the text or this is the email I sent you, right? It makes it easier for me to have that understanding now, looking at a more abstract way of looking at it within databases and event streaming and event sourcing and all of that stuff. And I kind of try to go back to real life experience and say, oh yes, this is what I could have done, or yes, this would have been the snapshot of this really painful situation I was dealing with, trying to get a payment out of this parent.
and then you realize how easy things could have been, right? And I think
Exactly.
that is one of the big problems with event sourcing. You really only get to discover the true value
Mhm.
when you felt the pain or when you've
Yes,
tried it, right?
exactly.
And I
Exactly.
think most of the systems are that we build nowadays are well, the components, the logic in the components is based on something that we have done before many times, and I think it's very valuable for us to learn from the pain
Absolutely.
we had,
Yeah.
and to not forget that, because we tend to focus on the pain we have now, and our memory forgets pain from the past. Right? So
Yes.
sometimes we see people struggling with event sourcing because it was different,
Yeah.
and then they think,
And
well,
it
let's
takes a
go
bit of
back
more
to the
work.
old, and it takes a bit more,
Yeah.
well, sometimes more work,
Effort.
yeah.
Yes.
And then they forget that, yeah, but the old system had problems as well, but we've learned to
Exactly.
live with those, and we tend to forget them as we move on.
Exactly.
Um,
No.
yeah. So
Yeah.
there's
I
definitely
think
a lot
that's.
of value. There's a lot of hidden value, I would say, in event sourcing, and you will
Yeah.
only know. So somebody said, if when you with event sourcing, you're preparing yourself for the questions you didn't know you had,
Right, exactly.
and
And I
that's
think
very.
that's important within any business. When we talk about a business logic, not just software tools and things like that. When you talk about a business as a whole, those are the things that you really want to go back. Those are the things that are really valuable to a business functionality and sustainability, because you have to go back and look at these things and see what exactly happened. Why was this business successful, and why was it maybe not successful in some other areas? So I think that's a really, really valuable point to have. So. Yeah. So, any other points that you'd like to add at the end of our lovely discussion?
No, I think we've proven the point that event sourcing is a little hidden gem, and that it
Yeah.
has a lot of value. We also need to be careful not to exaggerate it.
Sure.
Unfortunately, I've decided in some places not to use event sourcing, and then we had to retrofit it in because it really solved a lot of complicated issues. So you have to be careful of that as well.
Sure.
Yeah, there's a lot we need to learn, and a big takeaway for us is, for us as a community, I would say, is don't let the downsides of event sourcing distract you too much. Our mission as a company is to make that a fluent exercise, and of course
Yeah.
we're not there yet. It's not easy and simple just yet, but it is our goal to make it as simple as possible by taking away the pain of event sourcing, and allowing you to reap the benefits. So yeah,
Yeah.
if you discover pain, let us know, and we'll see how we can
Absolutely.
alleviate it. We're the doctors
Absolutely.
of event sourcing.
We'll make it better for you. We'll take a pain away.
We're working on a cure. Yeah.
Exactly. Making it easier, one step at a time. Fantastic. Thank you so much, Allard, for discussing this in a lot of details. And it's very, very insightful and beneficial for me. I appreciate it.
All right, you're welcome. Thanks for having me.
Until next time. Yeah.
All
Have a
right.
great day.
See you next time. Bye.
Bye. Thank you so much for listening. I hope you enjoyed our talk. Please join me next time as I discover sagas in Axon Framework. Until then, have a great time and happy coding.